What's going on, everybody? So, I'm gonna start doing some new stuff. I have a little goal for myself. Every day I would like to apply to at least 3 jobs or make three applying to a job and making a bid for a contract. I'm gonna say are like the same thing. Um, so I have some Python code here. I actually really like writing in Python. I think the syntax is really clean and it looks good. I think it's a very easy to use language. I've been experimenting with new languages and new frameworks. As I've shown, I have a working understanding of Java. Um, I liked writing in Java actually. I think it really helped me understand some aspects of computer science that I did not grasp from only using Python and JavaScript before that. Talking about languages, I guess I'll say the language I have the most experience in is probably JavaScript. However, I've also learned that it isn't the language. You can do anything in any language you want, so you should just pick one that you like. It doesn't really matter what other people are using it for. Because I am just making things for myself. I'm not building some, fancy application that thousands of people are going to be making requests to at the same time. So it doesn't matter. And I mean, will say this, I do want to make some stuff in Django. Although I don't want to get too fixated on, you know, just focusing on tooling. I really want to improve my ability as a computer engineer. I want to actually improve my programming skills, not just being able to read documentation and use other people's work, okay? Now, I'm not trying to bash frameworks. I love frameworks, okay? Obviously, like, frameworks are way better code than I could ever write. Well, maybe not ever, but right now. So, you know, I just decided I'm gonna pick a language I like. I like writing in Python. I think it's fun writing in Python, and the knowledge that you get doesn't really matter. It's what you learn, not how you implement it with code. Okay. So if I know that if I want to split a string, if I want to, iterate through an array, the ideas are what's important, not the syntax. Anyways, I'll stop talking about that because I'm sure you guys could care less about my opinions on that stuff. Uh, I digress. So what we got right here, we have we're looking to see if it contains duplicates. So I went ahead and I sorted the array first because it makes it easier so we don't have to check every index because the numbers are going to be coming in order. So I don't know. It's easier that way because if the number's small, then we don't have to go through every single one. But in the worst case scenario, we still have to go through every single one. Um, but this will make it easier. Um, oh, another thing too is if you do it in this manner, then it's like you don't. I think it's kind of like dynamic programming. I'm not sure if it would actually be considered dynamic programming, but it reminds me of this problem that I did regarding binary trees and how many steps it takes to get to the top. I'll be honest, I ended up having to look up a video because before that I didn't know binary trees. So obviously I'm not going to be able to answer a question that uses binary trees if I don't even know what it is. Okay, so I did some research. I learned what it was. However, I will say this: I did realize that I needed to probably use recursion. That occurred to me while I was working on the problem, so I was kind of, I was proud that I recognized that at least. Um, but I was trying to do permutation. I was trying to figure out how many permutations you needed to do. But really, the pattern of going up the tree, you could do a memoization, and I do know memoization, like caching data, so you don't have to keep looking up the results. But I know that you can do the stairs one by using dynamic programming. You don't actually need to cache it. So it kind of reminds me of that, kind of checking the next one while you looked in the one that you're currently working in. That didn't make any sense, but whatever. So yeah, then next we're gonna iterate through nums. It's important to do the range -1, and that's important because if we look here, we'll eventually go over the number of indexes if we get to the last one. So just take the range down 1. And obviously, if it's the last one, it isn't going to be a duplicate because they're all in order. If it can manage to go through the entire for loop without returning true, it's going to exit and it'll return false. Alright. I went ahead and already submitted it. Let me switch windows here. I went ahead and I already submitted it. I was really kind of disappointed to see how slow my runtime was. But on the flip side, one thing that I am very happy about is I absolutely crushed everybody. Well, I won't say everybody. Only 99.86%. I did quite a bit better in handling my memory, and I'm guessing that's because these people use like some sort of memoization instead of sorting it. I imagine that they probably made like a dictionary or like a hash map, and then they like probably stored the value of the letter with the amount of times it went in. And then if it ever is already in the dictionary, it probably returns true. I imagine that that's probably what they did. However, I'll say that doesn't work well because you're creating extra memory. Like you're creating a second point when all you need is nums. You just need it sorted. But my runtime's really slow, and I'm not really sure why it's so much worse than everybody else's. I'll be honest, once I seen this, I thought instantly, oh, I know why this is wrong. I need to use binary search. But there's not an actual target number that I'm aiming for. I'm just seeing if they're duplicates. I don't think binary search would work. Because I did. I stopped for a second, and I went to go implement it, and then once I started to implement it, I stopped instantly. I'm like, what number am I looking for? It's hard to, search for something when you don't know what you're searching for. But, well, we know what we're searching for. It's just we don't know the actual number. So how are you going to compare it and cut down the tree in half, or not the tree, cut down the array in half when you don't know what side of the split that you need to be on? Alright. So I'm gonna go ahead and I'm gonna stop it for a second. I'm gonna think about it and I'm gonna see if I can't improve my code in any way. Okay, I'm back. So I could not think of a way to improve my code. So I'll be honest, I looked at other people's code. I had already finished the problem. I exhausted it. I didn't see any way that I could improve it. And I still didn't know how all them other people got better runtimes than me. And then I looked into it, and it is because, funnily enough, they used the method that I was already talking about with the dictionaries or the hash maps, whatever you want to call them. So, so it seems like you can either choose to run your program fast, or you can choose to have better space complexity. The approach that I took has better space complexity because it does not require you to it doesn't require you to cache any data. Sorry, I lost my train of thought. It happens to me sometimes. It's still pretty early. I'm still drinking my coffee, okay? So yeah, it seems like you can either use a method using, dictionaries where your code is going to run fast, or you can use what I'm pretty sure is more dynamic approach and have a better space complexity. They both have the same big O notation. I thought that because I'll go ahead and I'll look So this was the solution I was looking at. So we still have we're still looping, and we still have an if statement. So it's the same as us, nested if and for. So they definitely have the same big O notation when it comes to time complexity. Sorry. So, that's cool. I don't really think I have anything else to say about this one. This one was really easy. Just to make sure and double check before I said something stupid, they do have the same big O notation. That's why I did this. See, just so y'all know I didn't cheat. I, gave it my algorithm, and then I forgot to ask what's the big O notation. So it gave me all this junk, and then bam. And it's still O of n, the other one's O of n. I already thought that, just double checking, and I wanted to show you guys I ain't cheating or nothing. So then I'm gonna go ahead, I found one that was very similar to it. It was duplicates 2, and I did duplicates 1. So this one, we're gonna give an integer array nums with an integer k, return true if there are 2 distinct indices, I and j, in the array such that nums I is equivalent to nums j, and the absolute value of I minus j is less than or equal to the value of k. Alright, sorry, I took off my sweater because it was getting a little hot, and then my baby came to visit us. Oh, baby kitty! Alright, sorry. So it was a little unclear what the problem was asking for. So what it wants us to do is it wants us to find 2 positions where the values are the same. The 2 values must not be farther apart than k. So let me look at this here. So we're just gonna look at one of the examples here. Alright, so they can be no farther apart than 3. 3 indexes. And it is 1. Alright, okay. So the first thing we gotta do is we gotta figure out, I'm gonna make notes on this. So first, find where a duplicate is. Okay. We'll just find the first duplicate. Actually, no, that doesn't work, does it? Yeah, so we're actually gonna have to cache this, I'm pretty sure. Alright. Yeah, so first we're gonna cache the index of the duplicates. Well, I'm trying to think of what the best way of doing this is. I'm gonna go ahead and pause it, and then I'll be back in one moment once I've been able to flesh out my thoughts a little bit. Alright, so I'm back. I did some thinking, and I ended up implementing my thoughts. So let's check it out. Oh wait, I'm actually gonna end the video because I'm about to go over YouTube limits.